Uh,
Um, so I have kind of an exciting topic on the agenda for today, um, and it's sort of a tricky one. Let me bring this up again. Can everyone see my like text and stuff on my screen pretty well?
Yes.
Okay, let me
yeah.
make this a little bigger. Okay. Um, sure. So, Andrew, I forget um, what you've seen and what you haven't, but did you see me do anything with iterators? Have you seen that or no?
I think I have. Yeah.
Okay. So now, I think last time we worked on into iter, which is just an iterator that you can use once, and it consumes the list. So you move the list into it in this method, and then when you use it, you can use it like this. But then if I try to use the list again, like if I just try to peek at the list, um, it doesn't like me because it says borrow of moved value list because it was moved into here. So obviously, for certain kinds of for loops like this one, where we're just reading all of the items, we shouldn't have to copy or destroy the list. Right now, we don't have a way to copy it, but we could make a way to copy it. That wouldn't be hard. But we shouldn't even have to copy it, right? We should be able to just create an iterator that points into the list and lets us look at it without copying it or moving it. So that's what's on the agenda. And so the way we had implemented the previous iterator, this into iter struct, was all it has inside of it is a list. This is some funny syntax, but it's just like this is a struct with one thing in it, the list. And then for our next method, all we had to do was pop items from the list. So we were destroying the list. Are you with me so far?
Yeah.
Okay. Um, so then what we want to do is we want to, I'm actually going to remove this because it's sort of a spoiler. We want to have an iterator now, and I don't know why she chose not to do this syntax for this one, but it's basically the same. It just has one field, next, and all that is it's a reference to a node. It needs to be a reference to a node and not just T, because we need to be able to look at this and then change it so that it points at the next thing. Like each time we advance the iterator, this starts out pointing at the head, but then the way the iterator will work is that each time they call next on the iterator, which is not yet implemented, but each time they do that, we'll change what this points to. We'll change it to point to the next item. And it needs to be an option because if the list is empty or we're at the end of the list, it needs to be none. Like there's no more nodes to point to. But there's a bug here, or there's actually a compiler error here, and it's really confusing. It says missing lifetime specifier. So this is one of the fancier features of Rust, and she takes the appropriate attitude towards it, which is, oh God, lifetimes, I've heard of these things. I hear they're a nightmare. She asks Rust to explain it, but it doesn't really help. It expects you to understand Rust already, which is good for documentation, but it's not good for learning. But what's going on here is that a lifetime, put this in a comment, a lifetime is just a named uh, span of time in our code. And I'll say a named vertical, no, named section of our code uh, for which some object exists. So, interesting. Okay. So this is useful. I actually don't love the way the linked list books just throws you into this, so I'm going to create a new file that just demos this. And 1 second, let me move some things around on my screen so I can see more things at once. That's not good. Right. Also, I totally understand it if you don't want to or if you have any reason not to, but I would love it if I could see one or both of you because it is weird talking into the void. Um, but okay, so
I would, but my room's not the most photogenic here.
I will not care. I will, but I can't speak to anyone else here.
Let me
Okay.
turn my camera on.
Okay. All right, you can do this. So let me see if I can even. I can't even. How do I? More options. Oh, okay. Wow. Okay. Um. So what's wrong with this function? Besides it being really stupid. Like, why doesn't it compile? It doesn't compile, but it's. I've hidden that from you somehow. I actually don't know why. But if I save it, it will. It will tell me why it doesn't. Is there anything we're missing here in this function?
The return type.
Yes. Yes. So if I save it, it says, wait, why is it not? Oh, it's yelling at me for a different reason. Let's see. Okay. Maybe it. Yeah, yeah, yeah. Okay. Mismatch types. So Rust actually assumes that it's like we wrote this, which is what you'd write for a function that returns nothing. If you do that, actually, Rust. I thought Rust might yell at you because you shouldn't be writing this because it's weird. It's implicit. But anyway, we need to be returning some sort of integer. Um, and I think we need to return. No, I think if we make this will be interesting. I think if we return an I64, not a 164, an I64, then Rust is actually perfectly fine. X turns into an I64. So this is the type inference at work. But let's stay normal and let's just say, okay, let's return I32. Okay, but this code works, right? Everyone understands what this code does. Now, what about what's wrong with this code? Okay, so I changed this so it returns a reference to X. And I'm going to change the return type so it returns a reference to an integer. But I'm not going to save it because that would give it away. What's wrong with this code?
Is it because the function's the only one with access to X?
Kind of. So there are a couple of things you could mean there. You could say it's because
Well, it's a
like
local variable, so it'll
it's a
be
local variable.
deleted. But I thought it was also
Okay,
an ownership thing.
right. You are totally right. It's just I want to explore exactly what those mean. So it's a local variable, and you said it will be deleted, and that's basically true, right? This variable only exists for as long as the function runs. This is also ownership. This function owns this variable, and it doesn't return this variable. Um, so this variable gets deleted when this function ends. I mean, those are sort of the same thing. To own something is to have the ability to destroy it, have the ability to drop it. So when I save this, it yells at me, but it actually yells at me in an interesting way. It says missing lifetime specifier. This function's return type contains a borrowed value, but there is no value for it to be borrowed from. Okay, interesting. Um, so a lifetime specifier looks like this. And if I do this, then it's going to complain about an undeclared lifetime name. So this is basically saying this is a lifetime, which I said earlier is a named section of our code for which some object exists. So I'm saying there is some lifetime A for which this reference is valid. So there is some span of time in my code, like span of time in my code's runtime, where there's some variable that this points to that exists. And by writing this here, I'm asserting that this reference is valid only for as long as that variable exists. Okay, so I can't prove to the compiler that this will work, because it won't work, because this is a local variable, like Sam said. Like this, there is no lifetime such that this, return type is valid, because, what is it? Because a variable will not exist as soon as we return. So there's nothing you could substitute in here. But it is yelling at me for a different reason. It says use of undeclared lifetime name. So lifetimes are kind of like variables. We need to declare them before we use them. Here I'm using them. But really they're more like generic arguments. Like here, I can talk about node, no, even simpler. Here I can talk about T. Here I can say that the type that this iterator returns is T. Now let's go simpler. I can say that this into iter contains a list of type T, but only because I declared here this type parameter. And this is sort of fuzzy, but maybe this is not how you're used to thinking of it, but that's how this works, right? We have to name T. We have to say an into iter is an into iter of something that is of type T in order for us to use T here. Does that make sense? To some extent?
So it's like generic keyword basically.
It's
and we'll use that later.
It's a generic parameter, but yeah. So lifetimes are the same. We declare them here. Like this is how you declare a generic function. So this is how you declare a function with a lifetime. So now it's not mad about this. I'm just saying, okay, returns 5 is a function that for some lifetime returns a reference to an integer that lasts that long. Now it's yelling at me because I can't return reference to a local variable. And it also explains it in terms of ownership. Returns a reference owned by the current function. Okay. Does anyone have an idea for how we could make this function? And you can change any aspect of it. And if you don't get there, it's fine. Does anyone have an idea for how we could change this function such that it can work? And all we have to preserve is that it still returns a reference to an integer.
It's global or asks it as a parameter.
Okay, yeah. So we could do two things. We could make it global. I'm actually glad you mentioned that. We could say static x equals 5, and this is how you declare global variables in Rust. You have to make them static. It's different from C, but static, I actually prefer the usage of the word static in Rust because it means like this thing has a static position, and you just always, like it lives somewhere in the binary. And it's clearer than in C where it's just sort of a mess. But in order to make a static, this is irrelevant, but we have to give it a type. I'm not even really sure why, but Rust doesn't want to infer it. Okay, so now I have this, and now I can return a reference to that, and I don't even need this. Okay, that works. What's interesting about this case is that we don't actually need this parameter because we can use a different lifetime here, because there's a special lifetime called static, which is valid for the entire duration of the program. So this X never gets deleted, right? So we can just say, hey, this guy returns a reference that's valid forever. And then the way the Rust compiler works is that every time we use returns 5, it makes sure that we use it in such a way that it obeys this rule, which is very easy. Because any use of this function is going to obey this rule because the reference it returns lives forever. but it also checks the inside of returns 5. It says, okay, does this actually return a reference that lives forever? So here it does. But if I had done like let x equal 5 here and done this, it would yell at me, cannot return reference to local variable x. I mean, that's true. I guess that's a more useful error message. But it could also just say like, this returns a reference with the incorrect lifetime, right? Because this only lives this long, really, but you're asking it to live literally forever with this type. Okay. What was the other option, Sam, that you said for making this work?
For a parameter. Also, you can
Yes.
overwrite global variables with local variables in this as well. That's good too.
Yeah. I accidentally showed that. Yeah, I'll talk about that. It's well, one, these actually had different names, right? This was uppercase X and this
Oh,
is
okay.
lowercase x. But actually, yes, you can do this as well. It's fucking weird. Now it doesn't like this because there's no such thing. I think you can. Wait, maybe you can't. Oh no, it's just mad at me because it wants local variables to be lowercase. If I make it all lowercase, oh no, you can't. So that, but in Rust you can do weird shit like this. I could do let x equal high, and then let x equal 5, and that is totally fine. The only reason it's unhappy with me is that I didn't use this variable. So if I like println x, then it's totally fine, except for this bit. But yeah, so you can shadow locals with more locals without even introducing a new scope, but you can't shadow globals with locals. I learned something. But yeah, you said parameter. Okay, so how would we do that? We would do that by saying we take x as a parameter, and it's I32, and we return amper x. What's wrong with this function so far?
We don't know the lifetime of the past in value.
True. So there's something else wrong with this function. And that's a good answer. I'm curious if anyone can spot the other thing that's wrong with this code. It's very related, but it's here. What's wrong with this bit? Andrew, Dima?
Uh,
So what are we claiming with this?
Reference to a static integer value, right?
Yes.
So
So are we returning a reference to a static integer value?
return reference to an integer, but
But not static, right? And this error message is wrong because I haven't saved. If I save, then it says can't return a reference to function parameter x. Okay. So actually, yeah, there's no way to make this work either. It doesn't matter what we do here, even if we do this, which is like the right thing in general, to introduce a lifetime and then say we return something that lasts for that lifetime. Because this is effectively the same as before. We still own this parameter. It's just that it's a parameter, not a local. But parameters are basically locals. They're just locals we were given. However, maybe what you were thinking of, Sam, was what if we took a reference and then we just returned that reference? This works. So this is a very silly function, but it just returns exactly what we were given. So let's try writing a test for this, or really just some code that uses it. And I'll just call it returns 5. Confusing, but no, I'll call it this. Whatever. Okay. So I guess we got to give this. I was naming it a silly thing. Okay. Let's make a variable and then let's call returns param with that variable. And it completely auto-completed. That's wild. Okay, nice. I guess. I hope that's not like an AI thing, because I've been using AI. I don't think it is. Anyway. So this works, and I can like print this. But we can break it, because there are actually special rules around how we can use this function. For instance, I could make a new scope. So this also represents a lifetime. If I declare a variable in here, then it doesn't exist out here. It has been deleted out after this curly brace. So I can do something like let yref, so this is a reference to y, and I'm not actually going to make that equal to anything. But then I'm going to say, returns per yref equals returns param of amper y. Or I guess I could just say of amper y. I could just say this, because it actually doesn't do anything. I guess that function's pretty stupid, but it still shows the machinery. Okay, what's going on here is actually, it's totally fine, I guess. Interesting. But we can't, the problem is we can't use this variable. Well, we could here. Okay, we can print yref here, and that's fine. Because yref just refers to y, and y lives this long. But then I can't print it down here. Why? Because y does not live long enough. Borrowed value does not live long enough. Okay, why is that? That is because returns param works for some lifetime a where its parameter is a reference to something that lasts that long, and its return value is a reference to something that lasts that long. So what is its parameter? Its parameter is a reference to y. So its parameter only lasts this long. But then we put it in a variable, and then we try to use that variable down here. So in order for this to work, this line would have to be within this span, this lifetime. But it doesn't work because y doesn't exist down here. So yref can't exist, or yref can't be used down here. Does anyone follow? Is anyone having problems following this? I'm probably going too slow, honestly, but I'd like to know if anyone has any questions.
I do have one question.
Yeah.
It's not because you're going too fast or too slow or anything.
Yeah.
I just didn't know that is how you define a lifetime for a variable,
Yeah.
or like the span you said. So that is what that does. So
Sorry, what is the question?
afterwards, you're just saying the brackets after yref. That's like the span.
Oh yeah. So
what
this
exactly is that doing? It's just separating a chunk of code and saying, hey.
This is a scope. These exist in most languages, I guess not Python, because it doesn't have curly braces, but these exist in like Java, C++, C, and they all work basically the same way, which is you can declare local variables within the scope. And then if the language has a way to like take a reference to a local variable, which Java does not, but C and C++ do, then this would be this sort of behavior would be illegal in C and C++. It's just that in C and C++, the compiler wouldn't catch it or might not catch it. And you'd have
Okay, that makes sense. I just never
undefined behavior.
used
Yeah.
that.
Yeah, no, this is sort of like the more realistic way of doing this. Like this, sorry, defining a scope out of nowhere is not normally done in real code. I have seen it used. Pina uses it in his test cases sometimes, and I think the argument is if you have like a long function and for some reason you don't want to split it up into more functions, maybe you just don't want to come up with a name for each of them, but you want it to be sort of modular. You want to have it do something here with some local variables and do another thing with a different set of local variables. You could just turn it into a function with a bunch of scopes in it with different local variables in each scope. And Pina does this for testing code, and it's kind of elegant. But yeah, this is really this is also the same thing as if this was in a different function, we'd have the same issue, right? Because a different function also defines a new lifetime. The function's local variables only exist until it returns. But yeah. So that answers your
But it's
question?
good to know that I was going
Yeah.
to say, it is good to know that the lifetime is for the variable itself and not the reference.
Yeah, I think that's the better way of thinking of it. So we write a little bit more detail. We write these little lifetime things on the types of references, but they're really talking about some span of time when running your code that something of this type is alive, right? So it is a lifetime of this thing, not a lifetime of the reference. Another important thing is that it might be very tempting to write something like this, where it's like, I want to return a reference that lasts this long, but this doesn't work. Like, I understand what you're trying to do. You're trying to say, like, I want to return a reference that lasts tick A long, but that's just illegal. The compiler, oh, that's a really unhelpful error message. Maybe if I do cargo run, it'll give me more information. Okay, it's having those issues. Yeah, no, it has a better answer. Borrow expressions, that's what this is. You could also call it a referencing expression or something. Cannot be annotated with lifetimes, right? Because we don't get to say how long this will last. It's the compiler's job to figure that out. We just put them on the types to say this is what we promised to uphold, and then the compiler figures out if we actually did. Okay, so I think that's a good thing because that's just a little bit more grounding for what the hell we're doing here. What the hell we're doing here is we need an iterator that references the items of the list. So what we need to say with lifetimes, like in human language, is that this iterator, we need to say, yeah, and interrupt me if you have any questions. This iterator needs to last, no. This iterator cannot be used after the list it references is freed. Okay, so I hope that kind of makes sense, right? Like this iterator references that list, so it needs to only live that long. So we're going to do this by saying there's some lifetime A for which this iterator is valid, and this iterator consists of an option of a reference to something that lasts that long. So this is really the lifetime of the list, and this constrains how we can use it as well. Right, so now we have to think about this. First thing we want to do with our iterator is say how you make one. And you do this by saying, okay, for a list, there's a new function iter, a new method iter that we can call to make an iterator from it. And you do that by making an iterator whose next field is the head, but we take a reference to it. And what is it yelling at us about? It says, we expected an enum option of ampersecond of node, but we found an enum, we found enum option of amper box of second of node. Okay. So what's going on here is that head is actually a box. Is that true? Yes. No, head is an option of a box. So then when we map it, this is a box. Then we took a reference to it, which is a reference to a box. So I think I may have totally misled you, Dima, last time. I think I explicitly said REST would solve this for us, but it doesn't, clearly. She describes how we fix this. She says, she's still talking about how we deal with lifetimes. I recommend reading this, but I'm not going to read it here because it sort of is redundant to what I've just said. Okay, yeah. This is important. She said, we've written references and function signatures before, and it was fine. That's because there are certain cases that are so common that REST will automatically pick the lifetimes for you. This is lifetime elision. So here's some examples. If we have only one reference in the input to our function, and here's an example of lifetime elision. We've been writing these functions that, like peek. Peek takes a reference to self and then returns a reference to something inside the list, right? We didn't have to write any lifetimes here, though. And the reason is because it actually follows this rule, which is that if we have a function that takes something of, it takes a reference to self and then returns a reference to something, it's going to desugar, it's going to turn into, like the compiler expands it internally into, we actually take 3 lifetime parameters. And these references could be to anything. So that actually doesn't apply to peek because peek only takes a reference to self. So we only take 1 lifetime parameter, and what's going on is all output lifetimes, so this lifetime, depends on self. They're the same. So that means it assumes that we're returning something based on self, which is a safe assumption because usually when we're writing a method that returns a reference, it's borrowing something on self. Like that's just a common pattern. And that's why this works. But if we wanted to, we could, expand it out and it would work just as well. Like this. I think. In fact, I may not live long enough. Oh. Like this. Yes. Okay. But Rust is nice and we don't have to do that. Okay. So here, though, we're actually running into an unrelated problem to lifetime elision. Let's see how she gets here, though. Okay, so she's doing the same thing that we're doing with this. We need to add lifetimes only in functions and type signatures. So she's actually working on next first, but let's just work on this. Okay. So she decides to add lifetimes here. Whoops. And it doesn't like it. And she's upset, which is lovely. We want to be storing amper nodes, but we're getting amper box nodes. Okay, that's easy enough. We just need to dereference the box before we take our reference. Okay. I should have looked at the thing beforehand, because yeah, this is what I would have done. The node it has too many layers of indirection. So what we need to do is this, which looks really dorky, but this is exactly what we need to do. Except we can't return a reference to local data star node. What does she do there? Okay. Right. So this doesn't work now because this function actually owns the box. So what would happen is we try to return a reference to the thing inside the box, and then we destroy the box. So what we need, instead of dealing with an option of a box, we need to deal with an option of a reference to a box. I think I showed this before, but that means we need to take this head, and then asref will return... what's going on now? Oh my god. Mismatch types, option of ampersecond of node, found enum, option of amper box. Okay, so what is node here? Node is a reference to a box. Okay, that's fine. We're dealing with a reference to a box. So what we need to do is we need to dereference it twice and then take that thing's reference. Right, so we had a reference to a box. Node is a reference to a box. Now, with this, we actually have the thing inside the box. This first one dereferences the reference to a box, and then this dereferences the box. But we don't actually want to return the thing inside the box. We want to return a reference to the thing inside the box. This is god-awful and ugly, but she gets there eventually. Yeah, Azref added another layer of indirection we need to remove. So now she just, I don't like this in the book at all. Okay, so she's just like, what if we use this method that we've never talked about, as deref? I will explain that, but first of all, I think she does talk about this option. Yeah. Before those were around, you would have needed to map amper star star node. And yes, it's really janky. So yeah, what's going on here is there is this thing called deref coercion, which is a complicated thing in Rust that I don't expect you to understand fully. It took me a while, and I just had to use it a lot. So practice, you know. But what it does is it turns things into the things they dereference into naturally. But sometimes it needs a little help. So the way we can help it is to say as deref. I don't think it likes this here because I'm already doing all this. Maybe this isn't where you edit. Huh. Oh. So you don't even need the map anymore. You just need to do this apparently. Right. Right. So what this is a option of a box of a node. What we want is just an option of a reference of a node. This deref is actually a trait as well. I've never seen this syntax. That's funny. But oh my god. Okay. Deref is a trait that things like a box implement. So it's like this is a pointer that can dereference to something else. But the way it actually works is it has a method that returns a normal reference to whatever's inside it. So for the box, where's this? For the box, the normal thing that's inside it is a node of type T. So if we call dot as deref, it just turns this into an option of a reference to that thing. An option of a reference to a node of type T. So that's exactly what we wanted. We wanted a reference to a node of type T. This is very similar to asref in that it's sort of magical, or it's a common pattern and they just automated. It's like, what if you had an option of a thing? What if you wanted a reference to it? Well, this is, what if you had an option of a smart pointer and you wanted an option of a reference to the thing behind the smart pointer? A smart pointer is just a pointer that does something fancy typically when you free it, when it gets dropped, that is. So box is a smart pointer because it frees its contents when it gets dropped. What is it yelling at me for now? Okay. It says I should consistently use lifetimes. If I ask it to fix something, okay, no, I do not want to ask AI to fix it. I wonder if it'll tell me how to fix it. It does tell me how to fix it. It tells me, interestingly, that there's no problem here, but that we should be using a lifetime here. That's sort of funny. This is a special lifetime. This is the explicitly elided lifetime. That means we're saying there is a lifetime for which this iterator is valid. But we are not bothering to name it, but we are saying that it exists. So as of now, I think Rust has decided that this code is fine, right? It can figure it out. It says, okay, this is a method on self. So it obeys, where is it? It follows this sort of heuristic. It's like, this is a method on self. So the result has the same lifetime as the lifetime of self, because you're borrowing part of self. And this is a struct, but we should probably refer to it consistently. And I guess I must be referring to it. Where am I talking about iter even anywhere else? There, but that's not the same one. Huh. Maybe it's just because I put the, I put TK here, so it needs me to put it here. Or it needs me to put something here. But it's useful to say, okay, or it's clearer at least to say this depends on this lifetime, or this depends on some lifetimes that the compiler has figured out. If we wanted to be fully explicit, we would say something like, this depends on the lifetime of self, but then we'd have to declare that. That's fine, but it's just sort of a mess. So we can meet it halfway, sort of, and say the compiler is figuring it out, but that's how it works. So let's get to the actual interesting method, though. First, I will take a drink, and if anyone has any questions, please ask me. Well, okay, so I'll get to the interesting bit. This is the, what if we want to actually make this an iterator? We want to implement iterator for iter of TK T, just to spell out its full government name, which means we need to declare the lifetime. And that's not enough. We actually need to say the methods, right? So we can implement missing members. Okay, so type item. We are returning not T. This is an iterator over amper T. And it's like, okay, we're declaring this without lifetime parameters. So using, okay. I think this is more complicated than it needs to be. The main thing is, we're defining a type here. We need to say this is, and it's a reference type. We need to say this is a reference type that lasts that long. Interesting. I guess I need to do this. That is surprising to me. Oh no, that fits with this. So I guess you do the lifetime parameter first. I don't know. Anyway, now we have the signature down. Now we need to actually say what it means to advance this iterator. So does anyone have an idea what it means to make this iterator move to the next element and also return the reference to the current element? Like, what sort of thing should we be doing in English?
Practically speaking, we would return the current item and then change the item inside the iterator itself into the next one.
Yes.
By the pointer.
Well, do we want to return the current item? Or I guess item is sort of overloaded. What do we want to return? Like, do we want to return, if we have a list of ints, do we want to return an int?
I mean, the reference to the current one. Or
Yes.
the next one, depending on how you're...
Right. We want to, so we have this field next, so that starts out pointing at the head. So I guess that's our current next item. We want to return a reference to that, and then we also, like Dima was saying, want to change what this points to point to the one after it. Okay. So let's see how we do that. I'm going to try writing that. Let the current thing equal, well, I mean, this is the right type. So we just need to save, this, self.next. And then we need to return next, or not next, current. But then in the middle here, we need to change it so that self.next equals, let me think. Yeah, we don't need to do star self.next because we're not trying to change the underlying item. We're trying to change what this points to. So self.next equals self.next dot. How does this work? Yeah, dot map, because if next is none, then we're done. So we want self.next to stay none. So map will only call the function we give it on cases that it are summed. So self.next.map n.next. Let's see. So n is a reference to a node, and n.next is an option of a box of a node. Okay, so that ain't right. Perhaps we want to as deref this. Because so next is, no, well, that's fine. Maybe we want to as deref this. This is now an option. Let's see. Okay, no. Mismatched types of some sort. Expected an option of a reference of a node. Found an option of a reference to a node. So somehow I ended up with two options. Which I think makes sense because I'm doing this wrong. How did she do it? No, she uses map. She just does node. Oh God. Okay. So she doesn't even have this temporary variable, but she's just mapping everything. Self.next equals node.next.map. So what am I doing wrong? What's in here? No. I'm getting two options here. That's funny. So I have self.next.map. This is a reference to a node. So I want its next, which is an option of a reference to a node, or an option of a box of a node. But I can turn that into an option of a reference to a node. But then I need to somehow... Is this how you do it? Can I just... This is so bad. Okay, no, I don't want to introduce all that. How does she do it? Self.next.map, and we have self.next equals the node.next. So that's our current, in our code, that's self.next. Node.next is the same as, no. In our code, that's the same as self.next.next. Okay. So maybe it is best to do it her way. Let's just try to understand her way. We start with self.next. If that's sum, then we advance it. Otherwise, we do nothing. Yeah, that makes more sense. If that's sum, then we call this function, and we say our self.next equals our nodes next, and then we just need to turn it into a reference. I think we can do that with as deref, but let's try this first. So we're returning all of this. So if it's that, then we need to change our iterator to point to the nodes next, but we don't need a reference. We need we don't need a box. We need a reference. No. Okay. What is she doing here? Well, we do need to, in the end, return a reference. Okay. So now we have a problem. So now we're returning a reference to our element, which is good, or an option of a reference to our element. And this node.next.map, we're mismatched types. We expected an enum option of this reference, but we found an enum option of a reference of a box. Okay, so I think the way you do this is you dereference the box and then you take a reference to it. But now we have the same problem we had before, which is we actually own the box here. So we can't own the box here. We need to .asref, and I already see what to do here, but just, okay, we need to do .asref, but then we have a problem because we just introduced an extra layer of indirection. Now we have an option of a reference to a box. So what we had to do is dereference the box, dereference the reference, dereference the box, then take a reference to the thing inside the box, and now we're good. But this whole idiom is god awful. So there's a better way, which is just, hey, we've got an option of a box. Let's turn it into an option of a reference of the contents. And that's what this does. Okay, so this actually just works. We just needed to add those lifetimes. I understand why she did it in the order that she did. She explains this, I think, once for both of them, but it's exactly the same issue, right? We have this code here and then here. Let me plug in. I'm really glad you guys are showing up even on the break. I hope that I'm somewhat helpful, though obviously I work better in person. So I think this works. Let's just see what her testing code is. I'm not going to go over the turbofish. That's boring. It's too complicated. What is that font? Anyway, that's really weird. Let's just copy the test. This is a very basic test. Apparently my formatter didn't like her way of formatting it, though. Push three things, make sure we get them in the right order. And the nice thing about this is actually after this, we can do things like operate on the list. This is something you could not do with the previous one. We can do something like list.peak, and we didn't actually change it. It's still going to be sum of amper3 because we didn't modify the list in all of our shenanigans. And if I run cargo test, something is messed up. Oh, it's this function. No, I didn't save. And now we have a problem with, okay, let's just also comment that out. Yippee! Okay. So yeah, this code is working, and we see that we can advance and then keep again. And then I did this out of order. She does it in better order. She says you can elide this lifetime because iter depends on self, but then that sort of looks weird because this contains a lifetime, and elsewhere we talk about it having a lifetime. So it's nicer, like to split the difference, to say it has this explicitly elided lifetime. Like, we're not saying what it is, but it is here. And why does that matter? Well, it matters because it still impacts how we can use this iterator. Just like with lifetimes, where we couldn't use returns per am in this way, there are certain ways that we can't use this list and this list iterator. For instance, we could not do something like let L equal list. No, what is it? List new. I guess it's let mute L. And I'll just push 5 onto it for the hell of it. I cannot do L.iter. I cannot say L.iter equals L. Well, okay, I can, but then I can't use it down here. I can't do like assert EQ L.iter dot next is sum of amper 5, which it should be in some sense, right? But the problem is L.iter doesn't last. Okay, well, it also needs to be mutable because next modifies it, but it doesn't last long enough. L does not live long enough. Barred value does not live long enough because L doesn't last long enough. Because L gets dropped at the end of these braces, but we need it to stay alive down here. So that's basically all I had to say. Does anyone have any questions? Because that was a lot. I know that didn't go as cleanly as I'd hoped, but I hope it sort of made sense.
Yeah.
Okay.
Yeah, I was gonna say I think I got most of it.
Okay, cool.
I feel like it's a little unnecessary to dereference twice than re-reference, but I mean, I guess I get
Yeah.
the idea.
Yeah, that's why we have this as deref. It's very silly to do that, and I really dislike it. I think this is my personal opinion. My personal opinion is that Rust Rust has deref coercion and maybe some other feature that's kind of similar. And the whole idea is like we're trying to solve the problem that C had, where sometimes you had to do X dot foo and sometimes you had to do X arrow foo, and I don't know, that's confusing or whatever. So let's try to avoid that. Let's try to automatically dereference when we want to, right? And I think this is very silly. It's not too silly. Like, it makes some sense because it is annoying. It's nicer to just be like, just have the language figure that out for you. But it leads to other pitfalls, and it leads to this having to dereference and then re-reference. I mean, that's what I don't like. It's so weird. It's like we did nothing. But no, we did do something because it was a box, and now it's not a box, right? So that's strange. And in my view, it's kind of like every language these days, or many of them, go to such great lengths to avoid writing semicolons because they think that semicolons are weird and unnecessary. And actually, in the end, like, semicolons are fine. I think that avoiding writing semicolons is it's doable, so I don't hate it every time. Like, Python does it fine, and Lua does it fine, but then I think Swift does it kind of badly, and Go does it kind of badly. So it's like everyone is obsessed with, like, we need to make the language simpler. And I think that Rust should have focused more on just being more about being explicit, because almost everything else in Rust is explicit, like very explicit. But then they try to dereference things automatically, and it leads to awkwardness. But that's just my 2 cents. And no one's going to make a language that's perfect for me until I make a language, and no one else will want to use that language. So, thanks again for joining me, and we will meet again on Friday. Though I may have to move the time. I don't think so, though. And of course, the recording will be posted. Hope you're all enjoying your break. I know I am. So, bye, guys.
Well,
Yeah.